Video number 112, graphing polynomials in factored form. Now what makes this particular function even more exciting, I suppose, is that you actually have the different powers. So you have a third degree binomial, and then you have a quadratic binomial. So what you'll have here is around the number 2, the function is going to behave like a cubic. And then around the number -3, the function is going to behave like a quadratic. So in order to know what that behavior is, let's first review those situations. So let's take a look at a quadratic, right? Obviously a quadratic has this behavior where the positives and the negatives, it bounces back up as you look at the negative here. So you'll at -2, you'll bounce back up to a +4. So there's 2 and 3. So this is the behavior of a quadratic, as it bounces back up as you get to the negatives. Okay? So here we're looking at the vertex. Well, the vertex originally for this problem is 0, 0. Here the vertex is going to be 7, 0. Okay? So your vertex is to the right 7 and up 0. Now, at the number 8, you're squaring 1. That's why the height is 1. At the number 6, you're squaring what? -1, which is a height of 1. At the number 9, you're squaring 2, bringing you up to that 4. So, and obviously you can check out the quadratics on this blog here. I have a number of different a couple different videos on graphing quadratics if you need to take a look at that. Okay? So, let's take a look at a cubic. I don't believe this has been shown here on the blog yet. A cubic looks basically like a little bit like an S. You have here, everybody agrees, I believe, 0, 0, that this is f of 0 is 0. F of 1 is 1. What's f of 2 though? It's 8. So it sends you up here, and it's very similar to a quadratic on the right side. Okay? Now the quadratic would have had you bounce back up this way, but what happens at -1? F of -1 is -1 cubed, which is -1. F of -2 is then, of course, bam, -8. So you're going to have right there. Now, this is the behavior of the cubic. You have this, you're turning to the right, then you're going to start going left. Okay? So go up and to the right, up and to the left. Up and to the right, up and to the left. So now this point here is referred to as what's called a point of inflection. Okay? That point here in the center is called a point of inflection. Unlike the quadratic, that point was referred to as what's called the vertex. So the vertex is the point where things bounce back up. This point here, the point of inflection, is where the points start to change direction. Up and to the right until you get to this point, change to the left. Okay? Now, what you're going to have here, all right, is we're going to shift the graph to the left 4. So 1, 2, 3, 4. Very similar to what we've looked at in the past with finding the vertex and things like that. So -4, 0 would be, bam, the point of inflection. All right. Then at 5, you're going to have a height of 1. Then at I'm sorry, not at 5. At -3, you'll have a height of 1. At -2, that's where you're going to go up to an 8. So you'll have this cubic behavior. And the cubic behavior is going to have, then over here at what? -5, that'll send you down 1. Then at -6, it'll send you down 8. So you'll have that point of inflection. There's that cubic behavior happening right there at the 2. Now, what does that mean about this graph? Here's what it means. I believe at this point we can talk about the zeros. I believe we all agree that the zeros are definitely at 2, 0. There's 2, 0. That's a 0. Okay? And negative 3, 1, 2, negative 3. All right. Now, hopefully you understand that the degree of f is 5, a 5th degree polynomial. The reason is because this is actually a 3rd degree x, and this is actually a 2nd degree x. So eventually, if you multiplied all this out, f of x would be a 5th degree polynomial. Now, there's a couple other things we need to understand. We need to take a look at the end behavior, and there's a couple videos on end behavior. What we need to ask ourselves is what's happening as x approaches infinity? What's happening to f of x? Okay? Then, as x approaches negative infinity, what's happening to f of x? Okay? Now, again, what we're seeing here, all right, if you were to multiply all of this out, what's the first term? F of x's first term would definitely be negative x to the 5th. All right? So if you were to, you don't need to multiply all of this out, but this would be the first term because you'd have an x cubed, you'd have an x squared, that's x to the 5th, and then you'd have this negative right in front of the whole thing. Which means in the end, if you were to look at end behavior, all right, if you were to just look at y equals, okay, negative x to the 5th, okay, what you'd basically have here is if when x is 1, y would be negative 1. When x is 2, y would be negative 32. So you'd have this. Okay? When x is negative 1, now here's the thing. This is an odd degree. Odd degrees are going to go in opposite directions. So as you can see here, as x approaches infinity, all right, let's call this, I don't know, let's call it f of x or whatever. We could say that f of x would approach what? Negative infinity. So as x goes to the, as you go to the right, the function goes lower. Now, that brings us over here. We're going to have that behavior. So the end behavior is going to be this. You're going to be going down and to the right, and then because it's an odd degree, you're going to have the opposite going on this way. So this is going to be the end behavior. Okay? Now, what's going to happen nearby the 2? This is going to behave like a cubic. So what you're going to have here is this. You're going to have point of inflection. See that? You're going to have a point of inflection. That's going to be the behavior over here. What's going to happen nearby the negative 3? It's going to behave like a quadratic. You're going to get a bounce. So eventually, you're going to get these two to connect. So this is going to be basically a rough sketch of the graph of f of x. Now, what we're looking for here is to find out the height. There's a couple ways to do this. One of the things you could do is you could find f of 0. Well, f of 0 would simply be negative times 3 squared times negative 2 cubed, which would definitely be positive 72. So that height would be 72. So this would be a pretty good model for what's happening for f of x. If you want to, you can plug in negative 2 to find that height. You can plug in negative 1 to find that height. You can plug in 1. But this is a pretty good rough sketch to show that you know and understand what's happening with these functions. All right, so you're definitely going to want to show this point of inflection behavior, though, to indicate that you understand this is a fifth degree. Notice here, notice how the directional changes. There's going to be 4 directional changes, right? We're going down to the right, change 1, 2, 3, 4. Count back the other way to the left. 1, 2, 1, 2, 3, 4. To the left 1, to the right 1, down 2, 3, and then 4. Alright, so there's your graph for f of x. Good times. Talk to you later.